Hi everyone, so now we're going to talk about how to divide imaginary numbers. When we divide imaginary numbers, the one big rule is that we can't have any imaginary numbers on the bottom of a fraction. And so what we have to do is something called rationalizing the denominator. When we rationalize the denominator, that just means that we're going to change the denominator in such a way that all of the imaginary numbers are gone. We can still have imaginary numbers on the numerator or on the top of the fraction, we just can't have them on the bottom. So let's get started. The first example is 4 over 7i, and automatically notice that there's an imaginary number on the bottom. So we want to rationalize the denominator. When we rationalize the denominator, the way we do that is by multiplying by the opposite version of the imaginary number, or basically the imaginary number portion of it multiplied by -1. So we're going to multiply by -7i. And as we discovered last time, when we multiply two i's together, it becomes an I squared, and we know that I squared cancels out to be a -1. And so this is why we want to multiply by that, by another imaginary number to get rid of the imaginary number. But what we do to the bottom of a fraction, we also have to do to the top of the fraction because we want to keep everything the same. So because I'm multiplying the bottom by -7i, I also have to multiply the top by -7i. So now what I'm going to do is I'm going to simplify both the top and the bottom. The top, we have 4 times -7i, which would give me 4 times -7 is a -28. And then it'd be I because there's only one I on top. And then on the bottom, we have 7i times -7i. So I'm going to do 7 times -7 gives me a -49. And then I times I gives me I squared. Okay, so let's continue to simplify. The -28i won't simplify, but we know that I squared is -1, so I'm going to say -49 times -1, which would give me -28 over -49 times -1 gives me a +49. Oh, sorry, I forgot the I on top as well. Okay, and then because it's a fraction, we can simplify this. 28 and 49, the common factor in this is 7, so I can divide both chunks by 7, which would give me -4i over 7, and that's my final answer. Now notice that it looks pretty similar to the original question, which was 4 over 7i, but we like this answer more than we like the original question because the imaginary number portion is on top versus on bottom. And remember, we cannot, there's this rule in math that says we cannot have imaginary numbers on the bottom of fractions. Okay, let's go through the second example. So the second example is 4 plus 3i over 6i. Once again, we want to get rid of the imaginary number on the bottom. We don't care about what happens on top, but we do want to get the I off of the bottom. So the way we do that is by multiplying by the negative version of that imaginary number, which is -6i. But what I do to the top, what I do to the bottom, I have to do to the top. So I have to multiply the top by -6i as well. So when we simplify this, when on the top, we have to put this, you want to think about the original portion of the top in parentheses, because the 6i will distribute to both chunks of the original. So we have 4 times 6i would give us 24i, and then 3i times 6i would give us 18i squared. And then on the bottom we have -6i times +6i, which would give us a -36i squared. Now, once again, we're going to simplify this by getting rid of the I squareds and turning them into -1s. So I'd have 24i plus 18, but instead of writing I squared, I'm going to put -1. And then on the bottom, I have -36. Instead of writing I squared, I'm going to put -1. Okay, now let's continue to simplify this. We would have 24i minus 18 over -36 times -1 gives me a +36. All right, and we're almost done. So we got all the imaginary numbers off the bottom of the fraction, which is great. Now we can actually simplify all of these numbers because they are all divisible by 6. So I'm going to divide everything by 6, and I end up with 4i minus 3 over 6, which is great, but we want to put it in complex number form, which means on the top of the fraction we have to flip-flop the 3 and the 4, which would give us -3 plus 4i over 6. Remember that complex form, you have to have the real part first and then the imaginary part after. And this is our final answer. And we know it's our final answer because there are no imaginary portions on the bottom, only on the top. All right, let's go to the next example. The next example says 2 minus 6i over 1 minus 3i. Now, this is the first time we have a complex number on the bottom with a real part and an imaginary part. So when you have a complex number, you still do it the same way where we flip-flop the sign on the imaginary part, but the real part also has to stay there. So what I'm going to do is I'm going to put both chunks in parentheses just so we can kind of separate it. And we multiply by 1 plus 3i. Now notice that I didn't change the sign on the real part, the 1. I only changed the sign on the imaginary part. And if you do this and FOIL correctly, then the imaginary part should cancel out. Now when we multiply by something like this where we just flip-flop that middle sign or flip-flop the sign on the imaginary portion, it's called the conjugate. So this is called the conjugate. I'll be using that word a lot, but it's not something you need to necessarily memorize. Just understand that you have to flip-flop that imaginary portion sign. So what I do to the bottom, I also have to do to the top. So I'm going to also multiply the top by 1 plus 3i. Now, we have to FOIL both the top and the bottom. So FOIL, we'll start with first, which is 2 times 1. So we got 2. Then 2 outside would be 2 times 3i, which would give us a 6i. Then we're going to do the insides, which would be negative 6i times 1, which gives us negative 6i. And then we have a negative 6i times positive 3i, which would give us a negative 18i squared. And then that's over, once again, we have to FOIL. So we're going to do 1 times 1, which is 1. Then 1 times 3i, which gives us a plus 3i. Then we have a minus 3i times 1, which gives us negative 3i. And then a negative 3i times a positive 3i, which gives me a negative 9i squared. Okay, so now we're going to simplify this by changing the I squareds to negative 1s. So we would have 2 plus 6i minus 6i minus 18 times negative 1 over 1 plus 3i minus 3i minus 9 times negative 1. Now we're going to simplify it by saying 2 plus 6i minus 6i plus 18, because a negative 18 times a negative 1 is a positive 18. And then over 1 plus 3i minus 3i, a negative 9 times negative 1 gives me a positive 9. Okay, now we're going to combine the like terms on top and on bottom. So on top, the real portions are the 2 and the 18. So 2 plus 18 gives me 20. And then on the imaginary portions, we've got a positive 6i and a negative 6i. Now, those things, a 6 plus minus a 6 gives me a 0. So there is no imaginary part. They cancel each other out. Okay, great. Now on the bottom, the real parts are 1 and 9. So 1 plus 9 gives me 10. And then the imaginary parts, we have a positive 3i and a negative 3i. Once again, they cancel each other out because 3 minus 3 gives me 0. Now, like we talked about, the imaginary portion cannot be on the bottom, and we don't care about what happens on top. So in this case, there was no imaginary number on top. It just ended up being a really pretty number, 20 over 10, which we could simplify because 20 divided by 10 is 2. My final answer is 2. Not all of your questions are going to end up like this. Most of the questions will turn out to have an imaginary portion on top and then something real on the bottom. But sometimes it ends up like this, where it just ends up like a really pretty real number. Okay, and then let's go through the last example. The last example is negative 3 plus 2i over negative 2 minus 9i. Okay, so once again, we're going to multiply by the conjugate, which is when we flip-flop that sign on the imaginary portion, which would be negative 2 plus 9i. Notice that I only flip the sign on the bottom part and then multiply that by both the top and the bottom. That is what you're supposed to do. You don't flip-flop the sign on both of them and then just multiply. Like I wouldn't multiply the top on this case by negative 3 plus minus 2i. Doesn't work like that. You have to multiply the same thing on top and on bottom, and we only flop the sign on the bottom. The reason why we're flip-flopping the sign on the bottom and then multiplying is because we want to change the bottom so it doesn't have imaginary numbers. So now let's FOIL. I'm not going to do the arrows this time because I think it got a little bit messy right there, but on the top we have the first numbers, which would be -3 times -2, which gives me a +6. Then outsides would be -3 times 9i, which would give me a -27i. Then insides gives me 2i minus 2 times -2, which gives me a -4i. And then the last ones would be 2i times 9i, which gives me an 18i squared. Now, on the bottom, we're going to do the same thing. So start back with the f on FOIL, which is first. -2 times -2 gives me a +4. Then outsides would be -2 times 9, which gives me a -18i. Then insides -9i times -2, which gives me a +18i. And then last would be -9i times +9i, which gives me a -81i squared. Okay, now we are going to get rid of the I squares by changing them to -1s. So on top we have 6 minus 27i minus 4i plus 18 times -1 instead of the I squared. And then on bottom we have 4 minus 18i plus 18i minus 81 times -1 instead of the I squared. Now we're going to simplify even further, so the top turns into 6 minus 27i minus 4i minus 18, because 18 times -1 is a -18. And then the bottom turns into 4 minus 18i plus 18i plus 81, because -81 times -1 gives me a +81. Now we're going to combine like terms on top and on bottom. So on top, the real portions are 6 and -18. When I add those together, I get -12. And then the imaginary portions, it's -27i and -4i. When I add those together, I get -31i. All right, and then on the bottom, we have 4 and 81 are our real portions. So 4 plus 81 is 85. Then on the bottom, and then the imaginary parts are -18i and +18i, which cancel each other out because 18 minus 18 is 0. And that's what should happen on the bottom. Those imaginary numbers should cancel each other out. And in this case, 12, 31, and 85 don't have anything in common, and so there's no nothing that we can factor out or simplify. So this is my final answer, -12 minus 31i over 85. And I really like that answer because it's in that complex form where the imaginary part's on the back side. And there we have it, how to divide imaginary numbers.